Hey there, crawlers. Welcome back. Crawlers is from Dungeon Crawler Carl. I say that from time to time. In this section, we're going to continue doing exponents. This is 2-3A, part 2. Our first rule is the quotient rule. This is when we have two monomials, one divided by the other. And if they have the same base, both x here, we can take the power and subtract. And I show it worked out as an example here, like it's m over n, and then we have m minus n. I have 8x to the 7th power over 2x to the 4th power. And so we do the 8 over 2 separately. 8 over 2 is going to give us that 4 right there. And then I wrote out 7 x's here, multiplied together, and I wrote out the 4 x's on bottom. You don't have to do this step. I was kind of showing what happens. As you go through, when you cancel out something on top and bottom that's the same, it gets replaced with a 1. And 1 times anything is just 1. So I end up with 3 x's on top times a 1, but that doesn't change it. And on the bottom, even though everything got canceled out, I still have a 1 because it's 1 times 1 times 1 times 1. Don't make the mistake of put a 0 there. All right. And then we don't need it divided by 1 anymore. So this is just 4x cubed. And you'll notice we had a 7 and a 4. It's the same as subtracting them, 7 minus 4. Okay. Pause the video. Go ahead and give it a try. You do x to the 8th power divided by x cubed. All right. I will assume you did. This is x to the 8 minus 3. X to the 5th power. The 0 exponent rule. X to the 0 equals 1. I can show you where it comes from. If I have x squared divided by x squared, well, we know that cancels out. X squared divided by x squared is like 2 divided by 2. It equals 1. So we have the same exponent on top and bottom, and we apply the quotient rule. So I can do the top exponent minus the bottom exponent gives me a 0. So I have x to the 0 there, but I know if I do the same thing, I get 1. So x to the 0 has to equal 1. Let's try it on another example where I don't show it all worked out like that. We have 3, and it's more steps in it. We're going to have like power and stuff like that. I've got 3x to the 1st power, y to the 0 power, z squared, all raised to the 3rd power. We start off distributing the 3 to each of these, multiplying it through. Okay. And so I get 3 cubed, x cubed, y to the 0, z to the 6. That's just 1. 3 cubed is 27. 27 times 1 will be 27. And then we got the x cubed and the z to the 6, and that bad boy went away. That was a 1. All right, you go ahead and give it a try. I've got 4x cubed y squared over times z over 4xyz. Go ahead and see what you get up with. Get it. Pause the video, see what you get. All right, I will assume you did. Let's take a look at it. We have the 4 over 4 first. And then I'm going to have x to the 3 minus 1, y to the 2 minus 1, z to the 1 minus 1. That is 4 over 4 is 1, x squared, y to the 1st power, z to the 0 power. This is 1, so we're going to multiply by 1. And when we have a coefficient of 1, we don't write it. And when we have an exponent of 1, we don't write it. So our final answer will be x squared, y, and good to go. All right. Next rule is negative exponents. X to the negative n, like that, is the same thing as 1 over x to the n. You just take it. If the exponent's negative, you move it to the other side of the fraction. Same thing here. I'm going to move it to the other side of the fraction. I could technically still write like a over 1 here, but I don't need to. Divided by 1 is not essential. And the goal here is to leave as a positive exponent. So we don't want to leave negative exponents when we can help it. So in my example, I've got a couple routes to do it. Let's look at them separately. Both of them, I factored out or found the factors of 30 and 12. And I left it as 6 over 6 or 6 and 6 rather than doing 2 times 3 because I recognize that they were both factors of it, so we can cancel those out. At this point, I noticed this was y to the negative 2. I have moved it to the bottom as y squared. And z to the negative 3, I moved it to the top. That's all I've done so far. Now we're going to take it and, well, the 6's cancel, leaving a 1. Then we're going to apply the whole quotient rule, 4 minus 2 there. We're going to do the product rule on top, 3 times, or z cubed. We're going to add exponents. On bottom, we got y to the 4th, y squared. We're going to add exponents. If we clean this up, we've got 5x squared, z to the 6th power, all over 2y to the 6th power. Another option is just going straight towards quotient rule right from the get-go. Okay? So if I go straight towards quotient rule right towards the get-go, 30 over 12 still has to stay the same. We're doing x to the 4 minus 2. Then we have negative 2 minus 4. And then I have 3 minus negative 3. So make sure you have 2 different negatives, and you're better off doing it in parentheses. That way you don't accidentally screw it up. That cleans up to 5 over 2, then x squared, y to the negative 6th power, and z to the 6th power. And then we don't leave a negative exponent. We move it to the other side of the fraction. The other side of the fraction, we have a denominator already. We just put it with the 2. And you'll see we get the same thing. Okay? And I did this here where you can see like the color coding. Like that color matches that one right there. And the Z matches that one. So I'm going to have that coloring in where I upload that like that. All right. You go ahead and give it a try. Pause the video, see what you get. All right. The top is 7 times 3. The bottom is 7 times 5. I can move the x to the negative 3 over to the bottom right now. I can move the y to the negative 2 to the top right now. And then I have z over 2 and z to the 2nd and z to the 4th. Here the 7's cancel, leaving behind a 1. I get 3/5. When I moved it to the other side, that should have been a positive 2. I've got I've got y squared, and I've got x cubed on bottom, and then I've got z to the 2 minus 4. This is going to clean up. That's going to be z to the negative 2, which I'm going to put back on bottom. So I'm only going to have y squared on top with the 3, x cubed on bottom, and then the z to the negative 2 moves to the bottom as z squared. And that'll be my final answer. All right. What else do we got here? Oh, power of a quotient. We'll take a look at a couple options here. This is where we have the power on the outside of a parentheses or a grouping symbol. And we have 2 different bases, at least one on top, one on bottom. And their exponents can be 1. They don't have to be. They can be any exponent. We just distribute through multiplication the exponent. So x to the m, y to the n, or x to the m, y divided by n on the inside with the p on the outside ends up distributing the same way. You can actually see this if you wrote it as y to the negative n and to the p, and then distributed using the power product of a product rule. And that gets us back to that. Okay? So they're related to the power of a product rule. This is the power of a quotient rule. Our first example has negative 2x y squared z cubed on the inside, divided by x cubed y squared z on the inside, and then all raised to the second power squared. So our first option here, what we're going to look at is just taking the 2 and distributing it to each thing. Then that, and that. Okay? So that's what I have here. And don't forget that the square is applying to the whole thing in this case because the negative's on the inside. So the new negative 2 squared is going to give me that 4. Then I've got an x squared on top and x to the 6th power on bottom after we distribute and multiply the exponents. And then so we're going to do the subtraction. X to the 2 over x to the 6 is like that. We get y to the 4th on top and bottom, and so we'll subtract the exponents, 4 minus 4. And we get z to the 6th power on top, z squared on bottom. We'll subtract the exponents. We get z to the 6 minus 2. When you clean that up, that's negative 4 for the exponent on x. And so we move it to the bottom and make it a positive exponent down below. The 4 is still on top. This becomes y to the 0, and y to the 0, well, anything to the 0 power is 1. And we already had a number, so we don't need to write the 1. And then 6 minus 2 is 4, so we got z to the 4th on top. The other option you have is like addressing these things on the inside first and then applying the exponent. So that's what I did here. I did x to the 1st power minus x cubed, or x over x cubed, x to the 1 minus 3. 1 minus 3 is negative 2. I got x to the negative 2. Y squared over y squared, I subtract exponents. 2 minus 2 is 0. I've got y to the 0. And z cubed over z, I subtract exponents. 3 minus 1 is 2. I got z squared. So we got this. We're going to take the 2 and now distribute it to everything individually. Negative 2 squared is 4. X to the negative 2 squared is x to the negative 4th. Y to the 0 is just 1. So when we square 1, it's still just 0. But I did the 0 here. And z squared again is z to the 4th. The x is the only exponent. We move to the bottom, and we again get that. All right, you guys give it a try. See what you come up with. Hit the pause. All right, I will assume you did. I think the second method was kind of a little bit easier, so I'm going to do that. I'm going to subtract exponents. 4 minus 1 will give me a 3. 1 minus 4 will give me a negative 3. 5 minus 5 will give me a 0, and I've got a cube outside. So that is negative 2 cubed x to the 9th power. If I distribute y to the negative 9, z to the 0. Z to the 0 is 1. Negative 2 cubed is 8. The x to the 9th stays on top. Y to the negative 9th moves to the bottom as a y to the positive 9th. And so we have 8x to the 9th over y to the 9th. And bam, we're done. And that'll be it for that video. We got several videos here. Notice I've got like 5 listed up here. There's 5 different videos for the first day. And we're going to start 23-A or A part 3 in a second. So let me stop the video.